So here we're going to look at Java generics. You've probably seen this before, so check out the code here. I've got an array list that holds strings, and then I can add strings to it. And I have an array list that can hold dogs, and then I add dogs to it. So classes can store references to other types of objects. And inside our class, when we allow someone to create an object of our class with that type of those angle brackets specifying the type, that's going to make a type be a variable. So the type of those objects will be a variable. Okay, I'm going to make a new class called favorites. Say I was trying to save my favorite numbers. I could say like int fav1 is equal to something, int fav2 is equal to something, int fav3 is equal to something. And here, whenever I had a favorites object, it would have these 3 instance variables. And I can even make a constructor where I set those things. And then I don't need to give them initial values. I can just create those instance variables. Let's look at what this would look like in a main method. So here I've created a new favorites object. I've given it the variable name f, and then it will have copies, or any favorites object will have a copy of those instance variables. So if I made another one of these, it could have a different set of values. But what if I want this to work more like an array list, where an array list can hold different types of things? I want to be able to have different types of favorites. So here, I'll say that my favorites needs to take in a data type, okay? That data type is going to be a variable. And now, instead of fav1, fav2, and fav3 being ints, they're going to be whatever that type is. Let's look at creating one of these. I could make my favorite strings, yo, team, and hi. In my constructor, instead of taking in ints, they're going to take in this data type. Okay, so now this looks way more like array list. Array list could take in a string, and I have to add the library. Okay, but we've seen array lists where array lists can take in a string, and then now that they've taken in a string, we can pass them a string. We can add hello as a string to that array list. And comparing this to the array list class, you can see that it takes in this thing e, which it uses as the variable for the type. And then when we look at the methods, the add method takes in something of type e. So when we said that our array list held strings, then that e became string. Let's make a dog class so we can add dogs as our favorites. So here I've made a dog class. It has an instance variable named name, and we have a constructor that takes in an input name as a string and sets that instance variable. Okay, now that these are in the same package, I can come back here and I can make a favorites that takes in a dog. So these are my fav dogs. There's going to be a new favorites. And here, instead of taking in strings, I need to take in 3 dogs. I'll make those 3 dogs. Now that I have 3 dogs, I can pass that favorite constructor 3 dogs. Because inside those angle brackets, I used the class name dog, that data type that's a variable is going to be dog. And so the constructor here, favorites, is going to expect 3 dogs. And I can give it D1, D2, D3. So to review, when we make a new favorites object, we put in here what type we want it to hold, and that type gets filled in for this data type variable. So here the type of the objects that favorites is going to hold is a variable. So because I put dog right here, in that favorites object, data type will always be dog. And you can see them all highlighted. Those all become dog. And right now I could put in any data type that I want into those angle brackets of my favorites, and that type, that object data type would get used wherever data type appeared. I can also put requirements on that data type. So I can say that it has to implement comparable. So I only want data types that implement the comparable interface. How I do that actually uses the word extends, which doesn't really make sense, but what this is going to say is that data type that I provide, like here I provided string and later on I provided dog, that data type must be a type that implements the interface comparable. And comparable as an interface is a little weird. It also takes in a data type. And you can see that string, that line 13, that one's fine because string does implement comparable, but dog does not implement comparable. So to have this compile, my dog class would need to implement comparable and compare itself to another dog. And oops, I have a typo, implements comparable dog. Okay, it still doesn't compile because we need to add those methods. So we have to add unimplemented methods, which gives us this compare to, and we can compare it to another dog. Now the dog implements comparable. Okay, it's not very interesting because it always just returns 0. But now favorites that takes in a type dog compiles because it meets this expectation that whatever data type I pass in, right, it's going to implement the comparable interface. And I want to note that this data type thing is really just a variable, and I could rename it. Here I've named it Colleen's data type, and all the code will work just the same. I could name it blah, and now blah is a variable that can hold a type. On line 13, that type would be a string, and on line 19, that type would be a dog. So just like when we use a variable x or y or z, this is a variable that holds a type, and the variable name that I picked here, blah, doesn't matter. Although I think blah is a little confusing, so I'll rename it back to data.